And welcome to Ladyada.
Hey everybody, welcome to Desk of Ladyada. It's me, Ladyada, at my desk, covered electronics. Got a couple prototypes that I designed this week. Mr. Ladyada, any news or updates, things people need to know?
Now we'll be celebrating a bunch of redesigns that we did, so we'll have some news on the site about that. Bunch of shows this week, tons and tons and tons of videos and more, so tune into that. What's going on your desk?
Okay, so let's show some boards that I designed. So it's actually gonna be mostly computer time, so give me a moment. So yeah, can you switch to the computer? So one thing I like to do is design Metro boards. These are boards that are Arduino Uno classic shaped. And the reason I like that is there's a lot of shields and accessories that use it, but also it's a nice big format that lets me have like DC power and SD card. Like feathers are beautiful. I love feather, but feather's really meant for like battery powered, portable, low power. Whereas a Metro is kind of like, okay, we can stuff everything that we want on there. Which is why, I often start with Metro boards when I have a new chipset. Although I haven't in the past, I'm starting to kind of get into that more. So um, this week I designed a Metro ESP32S3. You can see here. It was just a couple days ago. So I already have a Metro S2 Metro. And so I kind of uh, took the S2 design and kind of ripped it up and turned it into the S3. So let's look. Let me hide this left side, and then let's turn on the top layer and the silk and the T-docu, and we can show this off. So this is, unfortunately, it's a landscape screen and then a portrait, like a TikTok style board, but it's okay. I like to, Metros, I like to have them laid out this way when I do the work on them. So this is the ESP32S3, and this is the room layout. And another thing that I'm trying to do is whenever I do a Metro, I want to deck it out, like have like the best of the best. It's going to be a little more expensive, but it's already going to be expensive because we've got these through hole headers we have to solder in, and this DC jack and all that stuff. So for this board, I picked a N16R8. Now the S3 is interesting. The S3 modules come in like a plethora of different configurations, and what this means is 16 megabytes of flash and 8 megabytes of PS RAM. So it's like pretty much maxed out, but you still get the benefit of having it in that SECCE certified, ready to go, antenna tuned module. And it's not too big either. So it's nice. They've got the chip, and then I guess they figure out a way to fit, that much flash and memory inside the module. So I picked that. It's a little bit more expensive than what I usually use, which is a 4 megabyte flash, 2 megabyte PS RAM, and the mini modules that I use in the Feather don't come any bigger than 4 and 2. So to get 16 and 8, you have to go to these Wuru modules, but you don't have to go to the Wurover. And then give it USB Type-C into the native USB, a reset button, STEM QT port on the side here, JTAG connector. One thing I try to do is Metros always have the debug connector, even if they don't necessarily have a debug chip on it, like they don't have a FT232H or whatever, they at least have your standard SWD or whatever is relevant socket, so that you can connect a debugger. We've also got the debug pins here, RX and TX, and these are like the native UART. So you can actually connect a separate USB serial cable if you wanted to get like the low level ROM debug messages. Got some NeoPixel here, your standard NeoPixel, and also it's powered by a pin. So you can go into a low power mode. You don't have to use that 1 milliamp or whatever quiescent. LLED, that's a pin 13 LED on LED. Over here we've got a DC jack, 6 to 12 volts in, with an on-off switch that goes that lets you power it on and off. It goes through the pass transistor to enable or disable the DC jack. Goes into a AMS 117 5-volt regulator, and also a 3.3 volt regulator here, AP RT9080. You got the boot button, so you can go into bootloader mode if you're like, I really need to get to like a hardware, like ROM bootloader. And then down here, I thought this would be kind of, I don't usually put a micro SD card on something that has this much stuff going on, but I kind of was thinking that this could be useful for some of the IoT data logging things that we might be doing with Whippersnapper. So there's a micro SD socket and then a LiPo battery so we can like practice making this a portable project with a LiPo charger over here, charging status LED, and battery monitor, the MAX 17048. Although I could probably, we just don't have a lot of pins free, so this is a nice battery monitor that gives you percentages and stuff and is low power friendly. So yeah, this is, and we got USB-C. So the other thing is that all the edges got taken, like you have the DC jack, the antenna, USB-C, reset button, which like you really do need access to, on-off switch, I2C, battery, and micro SD, which means that normally I like to have the boot button exposed, so even with the shield you can get to the boot button, but like that just didn't make it through this. But you don't usually need the boot button because we have the teeny USB bootloader, and also within Arduino it automatically resets into the bootloader mode for you when you like open up the serial port at 1200. So you do need the reset button. So I think that's gonna be okay. But we'll see. So I'm ordering PCBs. I'll get here, stuff them, and try it out. But this is gonna be good. And oh, one thing that I did do that was different for the Metro ESP32S2. It was a very early design, and I thought that maybe Espressif would add pin relabeling or renumbering to the board support package. So relabeling is something that happens in many Arduino cores, like not the RP2040, ironically, but the SAMD21, SAMD51, at Mega 32U4, and other chipsets, and NR52840, which is the board support package we maintain. Pin 2, for example, here, isn't necessarily GPIO number 2. Arduino, like 2, could be any pin, which means that you don't have to worry about routing the pins. As long, you can make any pin 0 through 13 here, and they'll always number the same in Arduino. And that was actually kind of one of the powerful things about Arduino, is that like, logical pin 2 is not necessarily physical pin 2. However, Espressif did not add that capability. You have to like add that layer of abstraction into the board support package, and they never did it. So we thought that they might. We also thought the RP2040 might also, but it turns out that that didn't end up happening. And so that's why our Feather RP2040 has like kind of weird non-standard pinouts. And then the ESP32S2 also did. I kind of learned my lesson, which is basically like nobody's going to do logical pin remapping. You should always assume that the pins are not going to be remapped unless you manage the board support package yourself. So these are literally, other than RX and TX, and the reason is that boot 0, you don't want to expose this pin because, if you hold this pin low while resetting, you go into the bootloader mode, and even if you're like watchdog reset, you might end up getting into bootloader mode. And so this port pin 0 cannot be exposed here. So these two pins are, logical pins. I think they're, I don't remember, GPIO like 40 and 41, not 0 and 1. But then these 2 through 13 are GPIO 2 through 13. So thankfully, those are all available. And then the analog pins are logically remapped. But what's handy about having these in order is that we can then use them for connecting RGB TTL displays. I think you probably want to have them be consecutive pins. I think you have to be consecutive pins. And so you can use, this 11, sorry, yeah, we can use these 11 pins, and then maybe these pins for data and control. Maybe you can have like an 8-bit color, and then you need like DE, P clock, H sync, V sync, whatever. But you can at least kind of get something wired up. Anyways, and then you get, SD card and SPI as well, and I2C. So, we shall see how that goes. Okay, so that's one design I did. Okay, and then, next time, let's go to the overhead, and I'll show another prototype that I got in. So I'm slowly redesigning like hundreds of boards, and some of them are boards that need a fair bit of redesign. This is the 2.2-inch touchscreen shield for Arduino, an old design, and originally used an STMPE 610 or 811, which got discontinued over, the chip shortage. And then I found a replacement chip, but it was a lot of effort for me to go through and redo these designs. So I'm finally getting to them. And this is using the TSC 2007, and I made this reset button right angle and added a QT port. But I got these. So today I'm just kind of testing out the graphics test. So this is just a ILI 9341 screen, and that works great. So next I just have to get the touch screen part working, and this is I2C touch. So it's kind of nice because there's one less pin you need to have that's like dedicated for chip select. Okay, so next up, let's go. Yeah, one second. Let me open up the board. I gotta find out where. I gotta find out where I put stuff. I put it in that place with that thing one time. Okay, so go to the computer. So next up, we Carter and I are kind of trying to figure out how we can make piezo distance sensors like we have in the Adafruit shop. These ultrasonic sonar, these are very common. These are like, a couple dollar sonar sensors, and they use one transducer and one to send and one to receive. But one of the things that, we thought was like, instead of having this chip on the back that requires this like trigger echo annoyance, wouldn't it be cool if we could just do it all on a microcontroller, and then you could have I2C or UART or whatever protocol you want without dealing with this kind of like freaky, whatever, it's like the BIS0001 chipset, which is not a bad chipset. It works great, but like, what if you wanted to have something a little bit more custom? So he's been playing around with that, and turns out like to drive these discs, that whatever 38 kilohertz, you can drive it from a microcontroller pin, but you just don't get enough voltage peak to peak. You want to have a high drive voltage in order to really blast audio, that sonar, high frequency audio, off a thing and replace it. If you think about it, like if you were an animal and you want to do sonar, you have to yell really loudly to get the echo back. If you don't yell loud enough, the weakened echo won't reach you, won't be able to detect it. Which, it's like, I remember a couple weeks ago, people were talking about underwater sonar and how, like, if you happen to, like, be in the way of a submarine sonar, you'd actually, like, explode because it's, like, 50 billion decibels. Anyways, it has to be much louder than you think, but you don't hear it, obviously. So, to drive these discs, microcontroller pin, again, so you get 3-volt peak to peak max. If you do differential drive, right, where you have one, compared complementary outputs back and forth, you can get 6-volt peak to peak. Or maybe you're a 5-volt microcontroller, maybe you get 10 peak to peak. But what I thought was neat is Carter found this chip, the PEM8904, and this has 2 switch cap converters in it. This is like a Max 232, but for like piezos. And then you can set the gain with the 2 enable pins, and it will triple the voltage output and then give you a differential drive. So the output can be up to, even if you're running it as low as 3 volts, you can get up to like 12-volt peak to peak output, which will actually, you only need it for like a little burst, right? You just to send it a frequency and a signal, and it will send out that frequency at a boosted voltage rate. So hopefully we'll get much better distances, because he did kind of get a microcontroller to like send the signal and maybe see the analog response back. But he needs a higher voltage. So I don't know if anyone out there is driving piezo discs and you want them to be much louder, like the little tiny disc, check these out. Okay, so that's and then just one last thing before we go to IMP. If you want to go to the overhead real fast, I'll just show off some fun samples I got. From uBlocks, they sent me a GNSS / RTK real-time kinematic dev board that has like cellular. I think this is Bluetooth, um, RTK, and then a separate GPS, I guess. I mean, this is like an all like it's like SIM card, sorry, micro SD, SIM card, buttons, SMA, battery, USB-C. I mean, this is like a beast. Another, yes, this is maybe the cellular antenna. This is the cellular antenna. This is another LTE. So two cellular antennas and one L-band GNSS antenna. So this is the standard U-Blocks RTK, but they're like, oh, by the way, we're making a version that's much smaller. So this is a tiny RTK chip. These are like $200 a piece. So they're kind of expensive. So that's why I only got two. But it's very kind of them send them in. It's kind of got this cool like 3D construction where like there's a PCB and then there's another PCB like bonded on, or I don't know how the heck this is done. This is kind of cool, routed out. And then on the inside is on the top here is another. So it's a double-sided module, but with castellated pads. So this is used with you need a base station, but what this can do is give you not only your location on Earth, but then centimeter precision on top of that, using local timing differences that it can detect on a centimeter accuracy level. You won't get centimeter accuracy from GPS. That's not possible. The system just doesn't give you better than like 10 meters. But once you've gotten that 10 meters, now you can use this local base station to give you that you have a known location, you can get better precision. So, but you have to be within 100 meters of it to be able to get that that signal. Anyways, very, very cool stuff. So coming soon. This is unreleased. This is the Neo F9P. So I think this is like very, not even available in stores yet. But we got a sample, so it could be a cool feather or something. Would use this because it would fit much nicer. Okay, cool. All right, so let's go to anything else you want to do, or go to the
Great search time.
Great search. Go Great Search.
Where in the world is that part I need? The Great Search with Digikey.
The Great Search brought to you by Digikey and Adafruit. Every single week, Ladyada is a part of engineering to help you, yes, you find the things that you need on digikey.com. And I didn't get you that screenshot, but this is
Okay.
this is from a request.
Okay. Yes. This is a request you saw on social media. Jeremy Cook asked, is there such a thing as an SMT screw terminal block? And got some responses, some of which were not screw terminal blocks. So let's show what a terminal block normally is, because we've covered lots of terminal blocks. So a terminal block normally looks like this. Oh yeah, go to my computer. It looks like this, and it's a through hole soldering thing. And then on the top, there are these screws, Phillips or flathead, and you screw it to lift up this like pinching piece that then attaches the wires. These are very, 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 very common. They're great when you just have raw wires, stranded, solid. They can easily handle multiple amps of current, very high voltages. Classic wire to board connector. But the one thing is that you do need to have to through hole solder them. And so let's go to the overhead and I'll show an example. So this is a relay board, and this is a prototype, an earlier prototype, and you can see that it's got these terminals here soldered, and you can see like I hand soldered them in order to connect to the relay. And that, there's a couple reasons why you might not want to have through hole terminal blocks. One, if this is high voltage, now you have a high voltage exposed that somebody could touch, or if they're on a metal table, it can get shorted out. You don't want that. But also manufacturing wise, if you're not handling very high torque, like if you're not, people aren't really twisting it, then and they're fairly gentle. This is an extra step that might require hand soldering or selective or wave soldering, or there might be components on the other side that you want to not interfere with. So having SMT terminal blocks could be very handy. So good question. So I thought let's go to Digikey and let's see. You're like, does such a thing exist? Well, if it existed, Digikey would stop you, right? So let's go to the computer and we'll see. So we're going to look for terminal blocks. That's what these are called. There's a couple different ones. There's like the headers, plugs, and sockets, and then there's the wire to board. But this is the same group, so we're just going to click on terminal blocks. It looks similar to what we're looking for. So yeah, these are the standard through-hole terminal blocks. Oh no, there's like ones that have a little push button instead of screws. So you know, even though like they're often called screw terminal blocks, they may have pushy in parts. Okay, so first up, let's look only at active ones because we don't want to find something and then be disappointed you can't actually get it. Next, let's go to stacked so you can see it.
I got the screenshot by the way.
Oh, you want to go to it real fast or? Oh, there you go. This is the question. Hopefully they exist. We're going to find out.
Yeah.
30,000 views, but not
Yeah.
the same as a video, custom made for you.
Okay.
Okay, so back to the computer. Okay, so under mounting type, this is where the action comes. So you notice that there's a couple variations here, and a few of them look promising. This one, and then you option click and get the other one to surface mount. We're going to ignore the panel mount and through hole. It's actually like 500 options, which is great. I don't know the pitch that they wanted, but I'm going to, you know, assume it doesn't really matter. So the most popular one, and some people did mention it, and the least expensive is going to be Wago SMD terminal blocks. So these are like 50 cents in quantity. And this is, you know, it's not a screw terminal block. It's like a push type. Let's see if we can get the. Okay. They look like this, and then let's see if we can get the bottom. There's no photo of the bottom. There's two pads here that you solder in. So it's got like two very long pads for mechanical strength because there isn't any mounting bosses. And then wires go in the holes here, and then these are little push buttons that you use to release wire. So if you go to the overhead, actually, an example. So we've used these in this motor MOSFET driver. This is what I've got here. These are Wago blocks. So you can see they are mechanically very strong. They do take wires of various sizes, including, you know, even wires with ends on them. So you can push them in. And now this is, you know, fairly solid. And then, you know, you would have to press this to release. So, hold on, you know, it's focused. So you can push a wire in, although you can also press, and that, you know, that opens up the slot. And then if you want to remove it, you can press. Ideally, you press with something like a pen. Or I'm sure there's an official tool, but I like to use a pen. The only thing is, and I'll tell you that this, you know, it hasn't happened to me as long as you're using official Wago blocks, is that if you do overheat these, if you put them in a lead-free process and you overheat them, they can become a little brittle. And we've had early when we use these, we overheated the oven to get, you know, we wanted to make sure that our board got a good reflow. These got a little brittle, and then this piece broke off. Hasn't happened to us once we've like tweaked the oven profile, but it is something to watch for. Okay, so back to the computer. So you can get these Wago blocks in a variety of sizes. They have like 1, 2, and 3. They're fairly inexpensive. You know, you're not going to get anything as inexpensive as a oh, and then these are getting interesting. These METS connectors. Never seen these before. These are kind of cool. They come in different pitches. I think this is 508 millimeter. Sorry, this is 8 millimeter. This is 3 millimeter. So they do come, you know, they don't come in like 2.5, but they come in like your standard pitches. And they also have individuals. I'll say they don't come in like very wide numbers. You'll have to, you put them next to each other if you need a long run. However, this is not what the person asked for. They asked for screw type, not push button type. And I'm assuming that they actually care. So if you go over here under wire termination, you'll see that there's actually screw and screwless. So we actually want screw type. So let's look at those. And let's look also at normally stocking. Make sure that they're available. And then we'll look at, you know, at lowest to highest pricing. So there are, you know, SMT mount terminal blocks, and there's two that I found, and one, you know, they're both good. This one, you can see, you know, the nice long wires, instead of going down, they just got bent over. And then to prevent you from torquing and twisting the terminal block off the PCB, they have these bosses on the side. So this comes in 3. This is an Amphenol family. And they look pretty good. Phoenix also has a version, but Amphenol has, looks like 2, 3, and 4 size, which, you know, makes sense. And then you just, as many as you need, you just tile them together. Oh, actually looks like they have a couple more. They have 5, maybe more sizes. This one's kind of funky. And then Worth also has something similar. We did cover, and looks like, oh, interesting. When you get to 6, they actually, I wonder if they don't have the bosses anymore. A picture of the bottom. 1 second. Let me see if we got the data sheet here. We do not. Not published data sheet. Looks like they probably have the bosses coming from the bottom. But if you want a version that, you know, what I'm used to is you get 2 and 3 size terminal blocks, and then you stack them side by side. If you want those, you have to go, because these have, again, these have the bosses on the side. You can go with TEs. So hold on, let me look for TE. And we covered these on IMPI, and they're actually quite nice too. The Terminal Block series. So what's nice about these is that they have the boss underneath, not to the side. So you can have as many as you want side to side. And if you want, like, if you need a really long run, you know, you can just pick and place multiple next to each other. So these are, you know, these are pretty. You still need, of course, really chunky pads. And don't forget the mounting boss holes. You definitely need them. And don't make them too big. You want them to be a nice tight fit to get that mechanical strength. But out of this Terminal Block series, both are very good. So there are actually quite a few options. The only thing is to note, you know, you're going to pay more than through hole version. Yeah, so only use this if cost isn't a big deal, because even though you're saving yourself the process of soldering the terminal blocks, they're going to be more expensive than probably the labor that it costs to solder them in. So good when you don't want to have exposed pins. Definitely these are going to work great. Or you have something on the other side and you don't want the terminal block to like go through and interfere with those other components. So check out TE's board mount reflow terminal blocks. They do exist. And they're available on Digikey.
It's a great search.
Where in the world is that part I need? The great search with Digikey.
And thanks for joining us today, everybody.
There's a lot of
See
stuff.
everybody during the week. That was informative, fun, and more. Thank you so much, Ladyada. Thank you, everybody, for joining us in the live studio audience, otherwise online. We will see everybody during the week. Full week of shows and more. Night,
Thanks, everybody.
everybody.
Good night.